When you think of Earth's oceans, you probably picture the big blue we see from space. The Pacific, Atlantic, Indian, vast, endless, covering more than 70% of the planet. But what if I told you that's not all of it? Beneath your feet right now, whether you're standing in the middle of a desert, a mountain range, or a city sidewalk, there is another ocean. An ocean you can't swim in, can't sail on, and will never see, but one that may hold more water than all the surface oceans combined. This isn't science fiction. This is real geology, and it's one of the most mind-bending discoveries of the last few decades. For most of human history, we thought Earth's water was pretty much all accounted for. Oceans, lakes, rivers, glaciers, groundwater. Sure, we knew a little water seeped deep underground. But in the late 20th and early 21st centuries, geologists began finding clues that hinted at something far stranger. Vast amounts of water, trapped hundreds of kilometers beneath the surface, inside the rocks themselves. This isn't water in underground lakes or rivers. It's water locked at the molecular level inside minerals, hidden away in the Earth's mantle, far deeper than any drill has ever gone. And the evidence came from an unlikely source: diamonds. Some diamonds form over 400 kilometers deep in the mantle. Occasionally, volcanic eruptions bring them to the surface. Inside these diamonds, scientists have found tiny imperfections, microscopic specks of minerals called ringwoodite. Here's the mind-blowing part. Laboratory analysis showed these minerals contained water. Not liquid water, but water molecules bound within their crystal structure. The ringwoodite samples suggested that the mantle, especially a layer called the transition zone between 410 and 660 kilometers deep, could be absolutely saturated with this bound water. Estimates suggest there could be enough of it to equal, or even exceed, the total volume of all surface oceans. You might be wondering, how can we know about something buried hundreds of kilometers down? The answer lies in a combination of mineral clues and the way Earth itself rings during earthquakes. When a large earthquake strikes, it sends seismic waves racing through the planet. These waves travel at different speeds depending on the material they pass through. Faster through dry rock, slower through rock that contains water. By studying thousands of earthquake records from around the world, geophysicists have mapped out areas in the mantle where seismic waves slow down. A signature of water-rich minerals. When they compared this data with lab experiments on ringwoodite and wadsleyite, the pieces fit perfectly. These minerals, under mantle pressures, can store astonishing amounts of water. It's like discovering your seemingly solid basement walls are actually sponges soaked through. Now, when we say water here, don't picture underground lakes or rivers. This isn't a hidden swimming pool. This water is locked inside the crystal lattice of minerals, part of the actual structure of the rock. Imagine a sponge, but instead of holes filled with liquid, the water is actually built into the sponge's material itself. Under the extreme pressures and temperatures of the mantle, these minerals can hold incredible amounts of water without it sloshing around. It's not until these minerals are brought to the surface, through volcanic eruptions or tectonic shifts, that the water is released. And when it is, it doesn't come out as a gentle drip. It can fuel massive volcanic activity, influencing the landscape, the atmosphere, and even the climate. This discovery doesn't just add a cool fact to geology textbooks. It fundamentally changes how we understand Earth's water cycle. Most of us picture the water cycle as clouds, rain, rivers, oceans, and evaporation, all happening at or near the surface. But this deep mantle water suggests there's a second, hidden water cycle, one that operates over hundreds of millions of years. Here, how it works. Water from the surface gets dragged down into the mantle through subduction when one tectonic plate slides under another. There, it becomes locked inside minerals like ringwoodite. Eventually, Mantle plumes or volcanic eruptions release it back to the surface, sometimes explosively. This deep water cycle may help regulate ocean volume, climate stability, and even the movement of tectonic plates. It might even be one of the reasons Earth has remained habitable for billions of years. Water is a game changer for geology. Even small amounts of water in the mantle can lower the melting point of rocks, making it easier for magma to form and volcanoes to erupt. It also acts as a lubricant for tectonic plates. Without it, our planet might be geologically dead, like Mars. Some scientists even suggest that life itself owes its existence to this deep water. Without plate tectonics cycling nutrients and regulating global temperatures, Earth could have been a sterile rock adrift in space. So the water under our feet isn't just a curiosity. It's one of the reasons we exist at all. If there's this much water hidden deep underground, what else might be locked away in Earth's mantle? Some theories suggest vast amounts of carbon in various forms, maybe even diamond deposits on an unimaginable scale. There could be exotic minerals we've never seen on the surface, formed only under the crushing pressures found deep below. But unlike those diamonds or minerals, this water is not just valuable. It's vital. And the more we learn about it, the more we realize how incomplete our picture of Earth's interior really is. We will never drill 400 kilometers down. The deepest humans have ever reached is about 12 kilometers. The Kola superdeep borehole. And even that took decades. So scientists rely on indirect evidence. They study seismic waves, they analyze volcanic rocks, and they recreate mantle conditions in high-pressure laboratory experiments. Each method adds another puzzle piece to the picture. It's a slow, careful process. But over the past few decades, these pieces have assembled into a startling image, an Earth far wetter, far deeper down than we ever imagined. Here's the big takeaway. The surface oceans we know, the ones we swim in and sail across, are just the visible tip of Earth's water inventory. Beneath our feet, far beyond our reach, lies a hidden ocean locked in stone. An ocean that may dwarf all the water we see above ground. This deep water might be one of the main reasons our planet has remained geologically active and hospitable for life. It's humbling to realize that we've sent probes to the edge of the solar system, but we still don't fully understand the world under our own feet. So next time you walk across a city street, or a forest trail, or a sandy beach, remember, you're not just walking on rock. You're walking on a planet that hides oceans in its heart. Oceans you'll never see, but that shape every coastline, every storm, every breath you take. And that's the beauty of science. It reminds us that even the most familiar places hold mysteries as vast as any galaxy.